Hey everybody, this is Dr. Jacobs. Welcome to the first chapter of Research Methods. This is chapter 1, Scientific Understanding of Behavior. And so by the time that you're done with this unit, there's some things I want you to be able to do. I want you to be able to describe why it is essential to understand research methods. I want you to be able to explain the scientific approach to learning about behavior and be able to compare and contrast it with other ways of knowing. I want you to be able to identify and explain key features of the scientific approach to understanding behavior and be able to compare and contrast it with pseudoscientific approach. I want you to be able to describe and give examples of the 4 goals of scientific research: description, prediction, determination of cause, and explanation of behavior. I also want you to be able to summarize the 3 elements for inferring causation, which is temporal order, covariation of cause and effect, and elimination of alternative explanations. And then I want you to be able to generate examples of each of these. I want you to be able to determine whether a study is basic or applied research. All right, so let's go ahead and get started. Make sure when I have these unit learning objectives that you're able to do these things by the end of the unit, and so that you can keep up with the materials. There's a lot of information that we're going to learn, and everything that we're learning in these readings and any other readings that we're doing will be applied throughout the semester. So it'll be really important that you take the time each week to review these materials and make sure you can do these things. All right, so the purpose of research methods is to learn how to design and conduct quality research because it really teaches us to think critically. Research is conducted and applied in every single field in the entire world, whether it's music, whether it's nursing or psychology or occupational therapy, physical therapy, education, marketing, anything you can think of, there's research behind it. But it's also important to know that just because something comes from a research study doesn't make it quality research. Okay, so although we learn to conduct research in this class and the different elements into making it quality studies, there's never going to be a perfect research study. And that's something that you're going to learn a lot about. Like, you can change one element of your study, but just because you change that one element, sometimes there's consequences. Like, I don't know if you ever watched the show Once Upon a Time, but there's always consequences that go along with magic. And there's always consequences of doing certain things in research. So if you do one thing, there can be a drawback, and that can be really hard for students sometimes because they want to do the best that they can. And the only way to learn to do research is to do it and to make mistakes and to learn from those mistakes to make stronger quality studies. And so this semester we'll be doing a semester-long project where you can get your hands dirty and learn to do some of these things so that you have me to guide you through the process. So there are different ways that we can know things. There's intuition, there's authority, there's empiricism, and the scientific approach. And so when we learn about these, the first one that our materials went through was intuition. And intuition, we see this one quite a bit, or we hear about it quite a bit. And this is when people just have anecdotal evidence from the world around us. So we always know that, someone's cousin's husband's pet hamster's best friend had this wild thing happen, and that's the evidence people provide for whatever point that they're wanting to make. And so when people do that, sometimes you'll hear, well, that's just an N of 1. So if you took statistics with me, you'll remember from your handy dandy symbol sheet that the symbol lowercase italicized n is the symbol for sample size. So if you ever hear the saying that's just an N of 1 or just a sample of 1, it's saying that's just one case. And just because it happened for one person doesn't mean that's the typical experience, because we know from statistics that sometimes when we collect data, there are outliers in our data set. And so just a sample of 1 is not enough to create a theory. And so our materials went over something called illusory correlation, and this occurs when we focus on 2 events that stand out and they occur together. And there's a lot of examples that we see of this. We see this with different things like people believing that full moons cause increase in ER visits. We see this with learning style research. We see this with horoscope research. And so all these things we find when we do actual research, things that are intuitive for people, that they actually aren't real, but people, get really excited. So for example, if you hear someone say, "Oh, I was thinking of you and then you called," or "My dreams always come true." Well, we think those things because they stand out, and it's kind of neat when they stand out together. It's a fun experience. But when they look at the research, these things aren't typical, and it's not that you can tell a future. They've studied that scientifically. It's just that some of these things just occur together, and it's kind of neat. So authority, another way people know things is that they believe that someone who appears credible for whatever reason says something, and then we believe it. So it could be they look prestigious, trustworthy, respectable, and we just believe what they say because they're saying it. And this happens quite a bit. I think it happens a lot more often than what we want to admit. But just because someone has authority doesn't mean that we should take their word as gospel or absolute truth. So who do you believe when they tell you something? Like if you think in your own personal life, who do you just believe what they say without questioning? A lot of us have different people who we believe and trust their judgment and what they say. But in terms of like thinking about science and things like that, we don't actually accept anybody's authority. We question authority. And I think that was really confusing during COVID, because so many people were like, well, all these experts are saying different things, and they were confused because they're like, these people are supposed to have the authority, but they don't know. And I think that was actually a really big misunderstanding of the scientific process, which we're going to learn more about this semester. So another example of this is, how many times do you believe the information that are in textbooks? So textbooks are actually secondary sources. We'll learn more about primary and secondary sources in this class, but often there's a lot of mistakes in textbooks. When I first started working here, there's this really long book for the lifespan development classes, and I found something like 8 pages front and back of mistakes that were in the textbook, and I sent them to the publisher so they could be changed. If you've had stats with me, you know that I've been spending a lot of time writing a statistics textbook, and even then, no matter how many times I go through it, there's always going to be something that's wrong, or there's going to be a mistake or something that could be explained better. And that's because textbook writers like myself, we're all human. So it's just this one I think of questioning authority. Science does that. Again, many students don't realize that every single textbook contains errors. And sometimes students get really frustrated when I'm like, oh, so this is not right, or this is not right, because they thought that textbooks couldn't be wrong. So empiricism then, this is the belief that knowledge comes from observations. And so the scientific method is contained in this because we use the scientific method to collect and analyze data to gain knowledge. Okay, so the scientific approach. The scientific method allows us to collect data to make empirically based decisions. And there's different characteristics of scientific inquiry. For example, data plays a central role. Scientists are not alone. Science is adversarial. I thought that's always kind of dramatic in this book. Well, actually, let's go through some of these a little bit more. So data plays a central role. That's what this process is about. If you have a question, we'll write a research question, which is the question that we're asking as a researcher. And then we'll use statistics, like you learned in your statistics class. That was a prerequisite for this class to answer that research question. Something that's really cool about this, because we do quantitative research in this class, or we do research that's based in numbers, is that there's a right answer. So the sample that we collect, their data that we collect, we can get a real answer about what's going on. Something else about scientific inquiry, that scientists are not alone. We actually have an entire scientific community. Professors have a really interesting job, because we don't just teach. Teaching is actually only one of the 3 things that we do for a job. So we teach, we provide service to the university so the university can run on different committees, curriculum, accreditation, just all these different things. And then our third part, if you are in one of the sciences, is to be a part of the scientific community, whether that is going in and going to conferences and presenting posters, whether that's writing peer-reviewed journal articles and getting them published. And that's all a part of being a part of this community. And it's really comforting because people are actually pretty nice. I think this book paints scientists in a little bit of a more negative light than what it's actually like, even though, I mean, people can be kind of frustrating sometimes and hard in science, but we're a community where we can discuss ideas, and it's okay to argue and not agree with what other scientists are saying. But we're not alone, and we can work together to search for the truth. So here I thought it was really interesting that they're saying science is adversarial. Yeah, people don't always agree, and that's beautiful. That's something that I always put in my syllabus for this class and all my other classes, that it's okay to not agree. That makes life interesting. We can't have any progress if everyone's just nodding their head yes all the time. And so with science, in order for it to be science, any theory that you have has to be able to be proved or disproved, that you can use data to falsify that claim. If you can't test it to see if it's true, then it's not science. Okay. So if there isn't a chance that it can be proved wrong, it's not a scientific idea or theory, it's something else. And it can be a belief, it can be an idea, but it's not necessarily a scientific idea or theory. Scientific evidence is also peer reviewed. We'll learn more about the peer review process throughout this class. But basically what this is you spend a really long time writing your research manuscript, like we're going to practice doing in this class. And then when you're done with your study, you send it to journals to be published. You can only send it to one at a time. And then those journals will send out your article to 3 reviewers typically, and they will basically rip apart your article. They'll find every little thing they think is wrong with it. And then when they're done with it, they'll make a decision on whether they think you should completely reject it and not give you an opportunity to resubmit. Reject with resubmit. So that means they might accept it if you make revisions, or accept with revisions, and then just accept straight. Articles are never just accepted how they are. There's always going to be revisions, because when you get a whole bunch of really smart people, they're not going to agree on things, especially 3 really smart people. And sometimes it's really overwhelming to kind of go through some of the feedback that they give. For this class, when I give you feedback, if it's a lot, that take those as carrying notes. And sometimes students get really overwhelmed with that. But take it as I'm spending the time to give you the feedback so that you can grow as a scientist. I know how overwhelming it was when I started out in research. When I was in undergrad, I tried to write a research article, and I tried to submit it for publication. It got so ripped apart, and it was just for like a student publication too. But they had faculty who looked through it, and one of the things they said was like, well, you have to learn APA style. If you don't learn APA style, nobody's going to take your science seriously. And that was just actually the most kind thing they said, but there was just comments after comments, and I honestly ripped my paper apart. And I never thought I would do research again, and now here I am teaching it. And so with that, one of the reasons that I have y'all read the APA manual, and I actually mean read, because we will be applying everything from it. We will be testing over it. And I'll try to give guidance on some major things to pay attention to. But if you don't learn APA style and you're going on in psych, nobody will take your science seriously. And you'll have a lot harder time getting into graduate schools or getting into other programs that want you to publish, or if you're going to be a faculty member one day. And these are things that you really are going to have to learn, because they will be really good for your development, even if it's really hard to read sometimes. It's definitely worth it, because I don't want anybody that goes through any of my classes to have to go through what I went through to learn it the way that I did. So why do we need the scientific approach? We're really biased as humans, like super biased. And I would like to say I'm not biased, but I am. And we have some natural biases that we have in general, but there's more than just biases that we have, what we think of when we're talking about biases. And so when we use a scientific approach, it helps us to use data to make decisions rather than using our faulty judgment. If we don't use data to make decisions, a lot of times we might believe that pseudoscience is the answer, and we'll talk about pseudoscience in a little bit. So skepticism, again, if it's not testable, then it's not science. And science doesn't negate anecdote or intuition or authority. They're just not enough on their own to be explanations for everything. Okay. So there's a lot of things like scientists are skeptical of a lot of things. For example, we want to know who wrote the paper, who's the author, what are their potential conflicts of interest, what are problems with the methodology. In other words, like the way they set up their study that cause problems with what we're learning. So pseudoscience then is when people use scientific terms and demonstrations to make claims that are actually not based in science. These are fuzzy things. A lot of times they gain a lot of popularity because they sound good, but they're not actually based in any science. So for example, learning styles, pseudoscience, learning styles are not real whatsoever. There's so much research on this. If you had Lifespan with me, you know this because you saw the TED Talk. Essential oils, it works wraps, drinking collagen, and your shakes that you get from nutrition places. These are things that actually don't work. So things to keep in mind when looking at something that claims to be scientific evidence, be really wary if the claims can't be tested, if they're only using anecdotes and testimonials to support the product or idea. So I think that I saw something on social media recently where they had this cream and you put it on your face and it pulls all your supposedly all your blackheads out so you can just wipe them off, and all the testimonials were great, but if you went and looked at the little Facebook comments, everyone's like, it doesn't work like this, it's not that great, it's not doing what they say. It maybe smell good, made my skin soft, but it didn't do what they said. So if people are only using anecdotes or testimonials to support their product or idea, then it's likely not real. Sometimes they have evidence, wink, wink, so not real evidence, but evidence that are from experts, quote unquote experts, but they actually don't have any data to support their claims. And it's, these experts can be in any field. So it's really important to kind of pay attention to, okay, so what's the evidence that supports what they're saying works? If there's no independent verification of the results, so if someone says this is a product that works or this intervention that works, and here's our data for it, but it's only them and nobody else has been able to recreate those results, you're going to want to be kind of leery of accepting what they say. One of the really big things that you'll get out of the semester is I am hoping that you'll learn to read research critically. Ways to do this are to think about things while you're reading. So for example, who conducted the study? What research methods did they use? What did they measure, and were these measures high quality? Can these results be generalized? What were the results? Are there other studies that support this study's research and the results that they got from it? What are the limitations of the study? Like I said, there's no perfect research study. Every study will have limitations to it. So those are some things that you want to think about when reading research. What are some of the ethical issues that are involved with the study? We'll learn more about ethics later in this class. Some goals of behavioral science include description, prediction, and determining causes, and understand your explanations. So let's talk about each of these a little bit more. So description, psychologists and behavioral scientists are interested in behaviors and internal states. So our materials just said behaviors, but if we really look at some of the research that psychologists do, if they're doing something on depression or anxiety, often these are internal states that they'll have the participants in their studies report back on self-report, either through some sort of, measure that kind of says rate, like your sadness level. I'm making stuff up. This is not accurate, from 1 to 7 on a Likert scale. And then, or they might say, which of these symptoms do you have? Things like that. But those are actually internal traits. Feeling depressed is internal, although you can observe things like crying, right? That's a behavior, or sleeping, how long you sleep. Those are actually behaviors because you can observe them. But we're also interested in internal states. Researchers are often interested in describing the ways in which events are systematically related to one another. So if you remember from your statistics class, we learned about correlation. Most people learned about a Pearson product moment correlation, where we're looking at two variables and seeing if they're related. So if we wanted to see if there's a relationship between someone's level of depression and how much they sleep, we could give them a measure that kind of gauges how much depression, or the severity of their depression, gives us a number on that. And then we could see if there's a relationship between that and the amount of sleep somebody has. So how many hours, right? And then we see if they're related. However, with description, descriptive research like correlation, we can say there's a relationship, but we can't say there is causation. And that's one of the biggest mistakes people make in this class, one of the biggest mistakes that people make in statistics class as well. And so we will talk about that when we talk about how we determine causation. Another type of research is prediction, or another goal of scientific research is prediction. And this is really cool. This is where we see if certain variables predict other variables. And this is done all the time. For example, there was one study where they found that kindergartners, like when you go into kindergarten, the ability to identify letters, so not just say the alphabet, that's actually useless, but be like, oh, this is a B, or this letter is an R, or this letter is a T. Being able to identify letters, the number that they could within a certain amount of time, actually significantly predicted whether or not that same kindergartner would graduate from high school, which is really interesting. And something with that too, our University of Central Missouri, actually, for a really long time, and I don't know if we still do this, used to have a predictive algorithm where we could take information on first-year college students here at UCM and predict whether or not they would return for their sophomore year. Based off of different variables. And that was really, really helpful, because if we saw that a student had a really, really low chance of returning to UCM, we could offer interventions to help retain them. Because what a lot of people don't know is, although that you pay tuition and it's quite a bit of money, y'all only pay a certain proportion of what it actually costs to educate you all. There's a lot of development that UCM does in foundations to secure scholarships and donations, so that we can kind of try to defray the cost of what it costs to go here and get a college education. And so it is in our best interest, because we're investing so much money into the students that come here, to make sure that y'all are able to stay here and make it worth your time here to earn the degree. Another part is determining causation, and this is one of the most misunderstood types of research. To do this, you have to do something called experimental design. That is the only way to be able to determine cause and effect. So for example, we might have a sample of participants, and then we want to randomly assign participants to different conditions. So let's say we wanted to test the effectiveness of a depression medication, like fluoxetine, or the common name Prozac. So we could give one group the Prozac, and then give the other group the sugar pill, so they don't know if they're getting Prozac or not. And then we could randomly assign participants to be in these conditions, and then at the end see if there's significant differences in the level of depression after they've been on the medication for 12 weeks. Okay, so in there, the thing that's helping us with the experimental design, which we'll go over in more depth, is the ability to randomly assign participants to the different conditions. If we don't do that, then you can't say that something caused something else. In this class, a lot of times I tell students they can't study a lot of cause type things for their project, because a lot of times people are like, I want to know what causes depression. Well, in order to do an experimental design for that, to see what causes depression, you would have to randomly assign participants to be in one group where you're doing things to them to try to make them depressed or have depression, and then not do that to the other group and then see if it worked, right? And that's not ethical, right? So, and that's one of those things that we want to look at while we're studying research, is like, are the things that we're doing, are they ethical? And you all will go through a whole training on ethics, because psychologists have a really shady history of doing things that were not so great to people. So again, just because two variables are related does not mean there's a causal relationship. There's very specific things that you have to do to be able to determine causation. So evidence for cause and effect, there's a few things that you have to be able to do. You have to be able to have temporal order of events, covariation of cause and effect, and elimination of alternative explanations, okay? And so for temporal order of events, what this is it means that the thing that's supposed to cause the other thing has to happen first. So if you have the cause must happen and happen in time before the effect happens. If it doesn't do that, then it's not a cause and effect relationship. Another thing is covariation of cause and effect. This means that if the cause is present, so is the effect. If the cause is not present, then the effect's not present either. And then the third piece is elimination of alternative explanations. And this a lot of times comes when we're designing our research studies, that we're making sure that we control for things that might be an explanation for the results that we're seeing. And that comes through carefully controlled experiments. So another type of things that people do with research is understanding or explanation. And so a lot of times you want to explain or understand why certain behaviors happen. That's really useful information. Like, why do people with anorexia often have really bad outcomes if they have group therapy? Right? That is something that's been examined. And what they found is sometimes people with anorexia, if they go into treatment and there's groups, that sometimes there'll be some sort of competitive thing that happens and people will try to restrict their caloric intake and do other things to compete with other people. So there's also a difference between basic research and applied research, even though both of them are really useful. Basic research tries basically to answer fundamental questions about the nature of behavior. A lot of times this is dealing with more theoretical types things that are done in research labs that are really controlled. And then that is different from applied research, which is usually conducted to address issues where there's kind of some practical problems and hopefully some solutions. A lot of the research that I do is in suicide prevention, intervention, and postvention. And when I do that, usually it's more applied research because I'm looking into the ways that we can make people's lives better so that people don't die by suicide. One really big example of applied research is program evaluation, which is really, really common. And so this is, if we go to the Centers for Disease Control, they define this as a systematic method for collecting, analyzing, and using data to examine the effectiveness and efficiency of programs, as importantly, to contribute to continuous program improvement. So if we're going to break this definition down, it's basically saying, hey, when we have programs, we should check out and make sure they work or they don't. We should have evidence to support it. And if it doesn't work, we should find ways either to tinker with it or find something else to do. Often this research is used internally within organization and isn't published, even though it can be. And they offer entire classes on program evaluation. To get my PhD in school psychology, I actually had to take a program evaluation course, and we went out and did program evaluation for different organizations in Columbia. All right, so that's all for this chapter. Here are some of the references that I used to create this presentation. I hope it wasn't too bad to get through. I'm really excited for us to use this knowledge and do projects of our own. So I hope you have a great week.